This is part 2 on how you can use CreateAI and Microbit to build your own machine learning models that respond to the various different actions of your physical microbit. In part 1, we went over how to actually use CreateAI and how to set up your various different actions, record your samples, and then train your machine learning model to recognize those various different actions. That left us with a screen that looks like this. So as you can see here, when I perform my various different actions that I've set up in my machine learning model, we are going to see the percent accuracy of the program predicting what it thinks is happening. And in that bottom right hand corner there, we're also going to see that symbol that has been assigned for each one of these different actions, which represents the LED matrix on the physical microbit. One important thing to understand here is that this machine learning model right now is just happening in our browser on our computer, and it is receiving data via Bluetooth from our physical microbit. However, if I want to operate this machine learning model independently on my physical microbit, so I want to take this microbit and my project off and go do something else and have it respond based on this machine learning model that I've built, I need to take that code and go over to MakeCode and download that coding program onto my physical microbit so it can operate independently. So by default, the CreateAI program is going to give us an input block. So it says on machine learning waving, on machine learning thumbs up, on machine learning jazz hands, which are the actions that I assigned. It is going to display the icon on the physical microbit LEDs that I've assigned for each action. This is a great starting point to understand if your machine learning model is actually working, how accurate it is, if you need to improve it. But we can go beyond this. So the first thing that we will want to do is go over and hit edit in MakeCode. That is going to bring us over to the MakeCode coding environment. You have the option here to do block-based coding or JavaScript. Today we are going to stick with block-based. And for starting, we are just going to take this existing code blocks that we see here and download those onto the microbit. So we will just plug in our microbit again here. We are going to hit download. We are going to download this onto the same microbit that we did our machine learning model on. So we're going to hit next. We are going to pair if we are not already paired, and then it is going to download this program. So another important thing to know here is when it comes to using your machine learning model, we have kind of two options. So the first option is what we're doing here. We are taking that machine learning model and downloading it directly onto the singular microbit that we created the machine learning model on. Option 2 is where we can use a second microbit to actually have it radio communicate between each other, which is a little bit more advanced project that we'll get to in a second. Okay, so now that my machine learning model in MakeCode is finished downloading to my physical microbit, I'm going to unplug my physical microbit again. And now, when I start to perform my various different actions, we are going to see the LEDs on the microbit light up based on the action that I'm performing. So an important thing to understand here is when you are testing this model for the first time, if you are not seeing the symbol that you expect, it means that your machine learning model is not accurately predicting the physical action that you're doing. And so what that means is you may need to go back to your machine learning model and re-record some new samples. Or the other important thing to understand here is that sometimes if different actions, like let's say my waving or my jazz hands were too similar in terms of what they look like physically, the machine learning model might have a hard time differentiating between those two actions. So you will want to make sure that the actions you choose to set up in your machine learning program are distinct enough from each other that the program can recognize them. This was using the basic code blocks that are given to us from CreateAI once we train our model. However, you might want to go beyond this because when we're performing our different actions, sometimes it might be hard to see the symbol that's happening there. So what we can do is we can add on to these code blocks to trigger something else to happen when that action happens. So one of the student favorite one is using music. So your microbit V2 is equipped with a speaker that we can actually tell it, hey, when I'm waving, play this particular sound. So we are going to take this play tone code block and we are going to add it into each one of our input blocks here, and we're going to make sure to change the note that's happening for each one of the blocks. So depending on what actual physical action I'm doing, we are going to hear a different tone from the microbit itself. So because I have changed my code again, I need to re-download onto the microbit. So everything is still paired. Downloading. We will unplug. It's already sensing my actions. So If I'm doing thumbs up, I see the smiley face symbol and I hear my low C note. If I start waving, I see that icon and I'm seeing my middle C note. And if I do jazz hands, we're hearing the high A note. And again, this is a good way to test. If you find it's not quite being accurate, you may need to go back and train your model some more. This is good enough for what we need to do right now. So we're gonna go ahead and turn that off just so we're not listening to those noises a lot. This is a really great start. So from here, you can build out all sorts of different projects to have your microbit respond in different ways based on those machine learning inputs. That was option 1. Option 2 is where we might want to get a little bit more advanced and incorporate the radio function of your microbit and a second microbit to have something happen here and then something trigger over here. And using the second microbit in combination with the wrist strap and the charge is going to open up so many different project possibilities. You could use AI machine learning model to control a robot, a vehicle, or literally any other microbit controlled project. So for this particular example, we are going to use our climate action kit. We are going to build a simple project, and then we are going to set up the radio function to control our project from our machine learning model. Okay, so using the pieces in the climate action kit, I have assembled a little project here, and we have 3 different robotic components that are output components, meaning that it is going to relay information out into the world. It's going to show us something. It's going to react in some way when we tell it to. And I have one to represent each one of the symbols or the machine learning actions in our project here. So this first one, I have a continuous servo motor hooked up to this circular building block. And so what will happen is when I trigger that action, it's going to spin. In the middle here, I have an LED component, so I can control the LEDs to be whatever color and show however many pixels of the LED I want when that particular action happens. And then lastly over here, I have a positional servo motor, which will move to a specific degree when that particular machine learning model input is triggered. Those are all hooked up to my breakout board, and this is where I'm going to take my second microbit and plug it in here. So we are going to plug that microbit in, and then we are going to set this project aside for a second because we now need to set up 2 different parts of our project. So this microbit that's on my wrist here, this is going to be our sending radio signal microbit. So this is going to be the microbit that is going to detect the action that's happening from my machine learning model, and then it is going to send a radio signal to this microbit over here. This microbit over here is our receiving microbit. So it is going to be listening for that radio signal, and then depending on what radio signal is received based on the action that's happening over here, it is going to turn on one of these 3 robotic output components. So we are first going to start with programming this one. So we're going to jump back over to make code. We are going to keep these various different inputs here that we used before because it's handy again to know when I'm waving, is it actually detecting the wave or the action that I'm doing? And I'll know that based on the symbol and the note that is played. So we are actually going to keep those exactly how we are, but we're going to add on to them. So the first thing that we need to do is set up our radio channel. We don't have a on start block here yet, so we're going to go to the basic drawer and take one of those out. We're going to put it up over here, and then what we want to do is say on start, we want to set the radio group. The radio group is basically like a walkie-talkie channel. We're going to use one. If you were in a classroom where you had multiple microbits, you would want to make sure that each pair of microbits has a separate radio channel or a separate group, just so they're not interfering with each other. Once that is set up, now we need to decide what kind of radio signal we are going to send. For the purposes of this project, we are going to keep it simple, and we are going to assign each one of our different actions and each one of our 3 different robotic components a number. So we are going to use the radio send number block. We are going to add that radio send number block to each one of our machine learning input blocks. But right now, they are all the same number. We need to make sure that they're different numbers. So in coding, we always start at 0. So we're going to leave that first one at 0, and then we're going to change this one to 1 and this one to 2. So now what happens, depending on what action I'm doing, it is going to send out a different radio number. That is our sending microbit code. We are going to download this code now onto this microbit. Again, that's going to be our sending microbit. So we will hook up our microbit again. We are going to download. Going through the steps again, downloading this new program. Perfect. Now we need to set up our receiving microbit. So we are going to bring back our setup over here, and we are going to connect this microbit to the program. So now what we're actually going to do is set up a new MakeCode project. So we're going to open a new coding window. We're going to say radio receiving. We're going to hit create. This MakeCode project doesn't need any of the machine learning inputs that we needed over here, because this microbit over here is only receiving that radio signal. It doesn't care about what the machine learning model is. So that's why we've gone ahead and set up a new coding environment here. The next thing we'll need to do in this particular case, because we are using the Climate Action Kit, is add the Climate Action Kit extension. So we are going to type in the forward.edu extension. Okay, once you have the extension added for whatever robotic project you're trying to control, the principles here are pretty much the same. So the first thing that we want to do is, again, set up our radio group. So we need to tell this microbit what the walkie-talkie channel is that we're going to be communicating on. So we will go over here and say set radio group to 1. Now what we want to do is set up the various different inputs, or what this particular microbit is going to be listening for. So in this case, we are going to say on radio received number. So previously we had set up our sending microbit to send a number via radio, and now we want to say when that number is received. In this case, we also need to differentiate between the 3 possible numbers that we might receive, and we're going to do that with a logic conditional statement. So we are going to say, if true then, and what do we want to see is true? We want to see if the received number, so I'm clicking and dragging that block into here, the first option we had was 0. We will add our second and third options by clicking the plus. We can copy this little code block here. We'll change that one to 1. And this one to 2. So again, we started at counting at 0, so that is considered an option. So we have 0, 1, and 2. So we're saying we're going to receive a number. Depending on which one of these numbers are, you're going to do something inside. And what are we going to do inside? So in this particular case, again, because I want to control 3 different robotic components in my project, 1 to represent each action, we will start with the continuous servo motor. So to code my continuous servo motor, I am going to come over here to my motors drawer, and in my breakout board setup, I have that continuous servo motor connected to the left motor port. So I am going to choose this block right here that says set left servo to 50% power. That's the first thing that is going to happen. The second thing that I want to happen is my LED. So I'm going to come over here to sensors, and I am going to say set all LEDs to red. Lastly, I want to control my positional servo motor, so I'm going to say set left servo to 0, but I have this hooked up to the right motor, so I'm going to change that because left is just the default, and we don't want to say 0, let's say 90 degrees. Okay, these are the main 3 actions that I want to happen each time. I am going to also add a few additional code blocks here to my particular program, because I want to have the continuous servo motor, for example, turn on for just a little bit of time and then turn off again. I want to have the LED turn on for a little bit of time and then turn off again. And then I want to have that servo move to a position but then move back to the default. If I don't add these additional code blocks, the problem is that it will only execute once, or it'll only stay on and not turn off, which is not very helpful because we want our program to be continually responding to our various different actions. So to do that, what I'm going to do is just add some pause blocks in here. We're going to say turn on that motor for, let's say, 2 seconds, and then we will turn it off by setting the speed to 0. We will say turn the LED on for 2 seconds, and then we want to turn the LEDs off, which we will set them to black. And then we are going to say go to 90 degrees, pause for 2 seconds, and then revert back to 0. The other thing we want to make sure on is that we have a set right servo to 0 position, just so I ensure that this positional servo starts at 0 degrees. Now, we should all be pretty good to go. So what we're going to do is pair this new microbit, which it looks like it's already paired. So we are going to just download this program onto this second microbit here. So giving it a second to download. Okay, now that my project has finished downloading, I am going to go ahead and make sure that my breakout board is on so my components are receiving power. And I'm going to turn on my sending microbit here. And we're going to need to do this carefully because as soon as I turn this on, it is going to start detecting actions and then sending those radio signals, and it's going to do it continuously. So we might see all of the components turn on at once. That's okay. So we will go ahead and turn that on. And I'm seeing a smiley face already, so that means that is detecting the thumbs up already. So I will carefully perform that action. And I'm seeing the red LEDs, which was my thumbs up, so my radio signal 1. We will try waving. And then there's my waving, so that continuous servo motor is going. And then we will try jazz hands. So jazz hands, give it a second. That's my positional servo moving. Let's go back to thumbs up and waving. There we go. So as you can see, that robotic project that I quickly built is now responding based on the actions that I'm doing on this physical microbit over here, and then using the radio signal to send it from my sending microbit to my receiving microbit. And it's all based on that machine learning model that we trained in CreateAI. The possibilities here are obviously endless. We only did 3 actions in this particular project, but you could have all sorts of different actions. And with that radio function hooked up to a second microbit, you could control any microbit project that exists out there with this receiving microbit. So you could have this receiving microbit hooked up to a car or any other type of robotic project, and then control that robotic project with the machine learning model that you programmed over here. The possibilities for CreateAI are endless, and we hope you enjoyed this tutorial.